Okay, so we left off at example 2, and then we started to plot the points for this. So when we're sketching this graph, first I'm going to show you how you can take your rectangular coordinates and use those on your polar grid. So let's remember back to when we were in chapter 5 and we were graphing sine functions. So if we have 0, the sign at 0 is what? 0, and then if I add 1, I'm going to shift this up 1. Okay, and if you want to use your unit circle, feel free to do that. The next one, pi over 2, if I do sine of pi over 2, what is the sign? 1, so if I shift this up 1, it'll be at 2. The sign of pi is 0, so if I shift it up 1, I'm at 1. At 3 pi over 2, I'm at negative 1, so if I shift that up from negative 1, I'm at 0, and 2 pi will be at 0, so I'm going to shift it up 1.
So these are like circles?
No, this is rectangular coordinates. So we're just graphing this like normal for step 1, and then what you can do is you can use that as a table of values. So I want you to see how the rectangular coordinates are going to transfer to your polar coordinates. So your polar coordinates, you're going to have your theta value and then r. So go ahead and write down your theta values. So we're going to do 0 pi over 2, pi, 3 pi over 2, 2 pi. And again, it's just these points here, right? So this would be 0, 1, pi over 2, 2, pi 1, 3 pi over 2, 0, 2 pi 1. Okay, so we are going to use points from the graph on our chart. Okay. And based on our equation, do you guys know what type of limestone this is going to be? So remember, when A and B are equal, it's going to be a cardioid. So in this case, your A and your B values are both what? 1. Okay, so it is going to be a cardioid. So remember that your shape is going to be a cardioid, which will be heart-like. All right, so we're going to start plotting these. Yeah, Jonathan?
Which one is A and which one is B? How do I recognize this question?
Oh, your A value is just whatever is added or subtracted to the trig function, and then your B value is always what number is in front of the trig function.
Okay, so A is the coefficient, like the independent, like the constant, I mean?
Yeah, yep.
And B is just the coefficient of some function?
Yes, yep. Okay, and then I also want you to know, like, you can plug in any values from the grid, and I'm going to show you how you can use your table function to get these as well. But we'll start with the points that we have and plot those. Okay, so 0, 1. If I'm going to plot 0, 1, I'm going to start here, and then it's 1, so this is where my first point is. At pi over 2, I'm at 2, so I'm going to go 1, 2. At pi, I'm at 1. 3 pi over 2, I'm at 0, so I'm right here. And then 2 pi, I'm back at 1. Okay, so I don't have a good idea of exactly where these points are going to go from the points in my table. I'm going to show you how you can use your unit calculator to get a very, very precise graph. So to do that, first make sure that your mode is in polar mode. And then you also want to be in radians, since we're going to be working with radians on our polar grid. And then we're going to go to our y equals, and we're going to plug in 1 plus the sine of theta. Okay, and then this is all going to be about our table set. So if I go to my table set, I'm going to start at 0. And then, do you guys remember me saying yesterday what our scale is going to be by? Yeah, good. Pi over 12. Why pi over 12? Yeah, that's every line that's on your graph. So on your packet, it looked like this part got cut off a little for this one. But this is going to be pi over 12. This is 2 pi over 12, 3 pi over 12, 4 pi over 12, 5 pi over 12, 6 pi over 12. It's just these are the reduced values. Well, if I look at my chart, it doesn't say pi over 12. What do I have? I have decimals. So if you want to write the decimals next to it to help keep you organized, that's fine. Like this is going to be 0.26. This is going to be 0.52, 0.78. You don't have to do that. I'm just showing you this is the relationship. Okay, and then of course we know pi over 2 is 1.57. So when you're looking at your table, you'll know exactly what line to go on, or essentially you're just going in order. So if you have pi over 12, 1.25, this is our next one. So 1.25, I'm going to estimate is approximately here. And then from there, I'm going to 1.5. So on the next line, I have 1.5. And then 1.7. So that's a little bit above that. 1.8 on the next one. 1.9, really, really close to that. Okay, so what I've graphed so far is this part of our curve. Okay, and then once I get to 1.57, I kind of recenter that at the top because I know my 1.57 is at pi over 2. So now I'm going to go to my next one, which is 1.9, 1.8, 1.7, 1.5. And you can see, like, you don't have to plot every single point for every single one, but you do want to make sure that you have the correct thickness of the graph. And so I do recommend that you put partial points on there. Also, do you guys notice anything about the numbers on both sides or a relationship between the sides? Reflection. Yeah, it's a reflection, so it's symmetric.
Yeah.
Okay, so if it's symmetric, you can just take those same points and reflect it over the line of symmetry. Okay, so go ahead and continue with those points. So we just graphed up until pi, so the 3.14. Okay, so now I have 0.74 for my next line. And I know it gets kind of small as you're going in here. And then 0.5. And so this is going to curve right here. Okay, and some... Say it again.
Oh, wait.
Yeah.
So, like, when you go from high,
Yeah.
you want to find, okay, so hot, and then curve it up.
Yes, yeah. And then so once we get here from your 3 pi over 2, which at 3 pi over 2 we were at 0. Okay, and then you can see next to it, it's 0.03, so that's really close, 1.3, 0.29, and then 0.5. So wherever you were 0.5 over here is going to be the same over here as well. And remember, this is going to be heart-shaped, so that is like a slight heart. Some people say it looks like a booty, whatever you guys want to think of it as. That's what Mr. Toby said, and I'm just passing that little helpful thing around. Yeah, because it's like a grown-up saying booty, so that's just fun. Okay, so for common polar curves, this is a chart that I took from page 552 in the text. And we've already actually talked about some of these, like the R equals A is going to be the circle. That's what we did yesterday. And these are circles as well. They're just different parts of them here. But here's one that's going to be like a spiral. We're going to graph some of these today. This is a limestone, but it has an inner loop in it. We're going to see what that looks like. A cardioid, which we just did. A dimpled limestone. So a cardioid has a deeper ridge in it for the heart shape. And then a convex one, which means if it's convex, do you guys remember that from geometry? It doesn't have any inner points in it. And then today we're also going to talk about rose curves. And they're called rose curves because they look like flowers. Yeah, so you have the different petals. Okay, and then the lemniscates, they're figure 8 shaped, or they look like infinity. And I'm in the process right now. I'm trying to put together something where I'm going to let you play around and create different graphic art with the trig functions. So we're going to do that a little bit later on. I know some of you guys have already started playing around with that, which is great. A few interesting facts is the limestone. Actually, do any of you guys know what that means? Like in French? Or in Latin? Any of you speak Latin? The root word is snail. So you can kind of see here, like with the spiral. And the limestone is accredited to Blaise Pascal's father, which we know Blaise Pascal, and from what? Pascal's triangle. Okay. So they have a nice little math family. Okay, so we're going to sketch a graph of 8 cosine of 2 theta, for example, 3. And we're going to do theta and r. Oh, and just going back to this real quick, like if you were to do something like this on a test, I would have you pick any 5 points to put on here. Usually, well, they definitely can't be at the same spot, but you would plot these. So like this would be your A, your B, pi over 2 here would be B, this would be your C, this would be your D. Okay, so I would just have you label different points on there. Okay, so we're going to sketch a graph. In our table, I'm just going to put the unit circle values that we're going to use. And then, of course, we are also going to use our calculator to help us fill in the details. Okay, so, yes. Yep, exactly. So it will be a calculator test. Yep. So when you're figuring out what these are, remember you're plugging theta into your equation. So it's 8 cosine of 2 times 0. 2 times 0 is 0. Cosine of 0? 1. 1 times 8? 8. Okay, so what's 2 times pi over 2? Just pi, right? The cosine of pi is? No? Yes, -1. So -1 times 8, -8. At 2 pi, it's going to be 1. So can you guys see what's happening here? It's going to start going back and forth. Okay, so it's 0 pi and then 2 pi. Our next one is going to be, what's going to happen when you do 2 times 3 pi over 2? Bless you. Yeah, 3 pi. So then that's going to be -8. And then we're going to go to 4 pi.
Which is
Okay, so if I just plotted those points on the graph, that's not going to give me a good look at what's happening. Now, when I go to plot my first point even, if I go 0, 8, I run into a problem, right?
There's no 8.
Yeah, there's no 8. So if you need to scale that by something else, that's fine. This is all I want you to write. Scale by, and then whatever you want to go by. So in this case, we'll go by 2s. So at the top of your graph, just write scale by 2s, and then I'll know.
So we don't have to label it or anything?
No. I think it's just going to be too hard to label it with all the points that are going on 2. So just at the top, you can straight label it, and then you'll be good to go. So I have 0, 8 first. So 2, 4, 6, 8. Now, my next point is at pi over 2 negative 8. So, any trouble graphing the first point? Okay, so my next one, if it's pi over 2 negative 8, instead of going towards pi over 2, I really have to go, I have to go away from it, so 3 pi over 2, so 2, 4, 6, 8 here. You are going to graph these in order, and so we are going to swirl from this point to this, okay? And I'm going to show you how we're going to do that. And I'm going to show you, too, on the calculator how this is going to happen. Now, when you do this on your calculator, it's only going to show you one time. And then from there, it'll just go to it. So just watch this graph it so you can see the formation, how it's graphing it. Okay, you guys ready? Okay, so it's going to start here, and then it goes whoosh, whoosh. My other classes like my sound effects today. Mine is just the standard. So, or I did negative 15 to 15. Oh yeah, okay. So it's just we'll just zoom out. Okay, so if you just go to zoom out, bada bing, bada boom. So go to zoom, zoom out. If anybody's getting hard angles, you'll know what if you see it, you'll know what I mean. It literally looks like triangles instead of the soft petals. Let me know. You can really just reset your calculator, and then it doesn't have that. Just, where's your graph? Oh,
That's why I'm changing my window. No, let me change my window.
okay, it should be 2 theta.
No, but it still doesn't work.
Okay, but you have
So I'm changing my window to yours.
It's fine. Okay, so now I'm going to go back to my table. Yeah, 2 pi, and then pi over 12. And then just do negative 15 to 15 by ones. Here? Yeah, negative 15 to 15. Yep, by ones. And then just negative 10 to 10 by ones. All right, so our table set started at 0. We're going to go by pi over 12. And let's look at our table. If there is, I don't know how to do it. Sorry. I can ask the other math teachers at lunch and see if they know. Okay, so 0, 8, and then this one is 0.69. So at pi over 12, remember I'm going by 2s, so 0.69 is just about halfway. Okay, and then the next one is going to be 4. So again, remember I'm going by 2s, so 2, 4, right here. And then my next line, I'm at 0.
Wait, where's 4?
That.
What 2 is?
Yep. And see how it's 1, 2. So you just go 1, 2 lines from there. And then once you get to your line pi over 3, you can see it's negative. So if it's negative, that means I'm going to go back, which we want because we're going to swoop it and loop it with the 3 pi over 2. Okay, so to get from this point to this point, instead of doing this whole thing at one time, I try to take pride in my petals and make them each with care. So this would be our first section of the curve. So what I would do is okay. Oh no. That doesn't bode well, okay? But so here's a little shortcut. Remember we said that they're symmetrical. So if this is here, this one is going to be right across from it.
This is actually fun. It's like a flower.
I know. Isn't it cool? Yep. And so, I mean, when you graph it, you don't have to go in order. Obviously, I'm not going to know.
Flower?
Yes. You are the second person today who has wanted to color their flowers. Okay. So it's more like a daisy. It's a daisy curve. A rose by any other name would smell as sweet. Okay, so we've already gotten up to pi over 2, so it does take some concentration, and so if you need to like recenter yourself, I usually do it at one of the values I know. So the 1.57 is at pi over 2, -8. So then my next one is 7 pi over 12, and I've actually already graphed those as well. So like the 7 pi over 12 was the reflection because they're negative. So I'm going to go to pi. Okay, so at pi, I'm at 8. So 2, 4, 6, 8. Do you guys notice that the numbers are going to be the same for every single petal? So remember before we had the 6.9? This is going to be the same thing. And you can make them symmetric on both sides. And then the next one was 4. Is that okay? Okay. You guys doing okay? Okay, and then so then I'm going to loop this through. Oh yeah, that's good. Let me look at yours. Because you should have, what we want to do is we just want to have an accurate thickness of the flower petals.
I don't understand like what we're gonna use this for.
This is actually can be used in a lot of graphic design. So when you're creating a beautiful wildlife habitat for your beautiful animals, maybe you want to put some exotic flowers in there. Okay.
Graphic design, they actually taught
Really. I have a small space in between them. All right. Okay, so let's move on to the last one.
I don't know if I did that right. Is this right? Yeah, it is.
Okay, so we have 0, pi over 2, pi, 3 pi over 2, 2 pi. Okay, and go ahead and find your R values.
I was going to yell my name really loud so anybody doesn't watch it here.
Okay, so we should already have our table done. And again, we're going to use our table, and I'm going to show you how you can do that. I know some of you guys have already graphed it. Can you tell what special shape this is?
The looping one.
The double loop.
The limestone with the
Enjoy.
inner loop. Right? And then, so again, if you're having trouble like with the decimals, if you want to label each one with those partial decimals because that's easier for you, please feel free to do that. You don't have to do that. If that just helps keep you on track, you are welcome to. It's a good strategy to use. All right. So I'm going to my table set. I want to start at 0. I already put my equation of my y equals. And now I'm going to my table. So 0, negative 1. Anytime it's negative, we're going to go back. So we don't go towards 0, we go away from it. So this is our first point. And this is actually part of the inner loop. Okay? And then our next one at pi over 12 is negative 0.93. So that's really close to that. Don't feel like you have to plot every single one of those points there unless you want to. So we'd have 0.7, which is a negative, a 0.4, which is a little bit less than half here, and then at 0.
When you just plot, pretty low.
What's that?
I just plotted the table.
That, yeah, so when we do this part in order, I'll actually loop it through with you. So like I said, this is the 0.26, this is the 0.52, the 0.78.
How do you tell what these ones are? Is there like something you add?
Say it again.
How do you tell what these ones are? Is there something you add to each one?
Well, yeah, you could add pi over 12. You could keep adding pi over 12, and that's what it would be. But you could also just look at the order, and you could go around the circle and do that. Okay,
Because I
so
don't know what that's equivalent to.
what's that?
What this is equivalent to.
Oh, you could do pi divided by.
This divided by.
Well, that's gonna be that's negative, so it'd be negative. You're negative pi over 12. Okay, so you have the 1.04 is what I just graphed at 0. So at 5 pi over 12, it's my 0.48, which is going to be right here. And then at pi over 2, I'm at 1. Okay, so this is what I've graphed so far. Just this little part. Okay, and this is actually going to be part of the inner loop and now part of the outside. So after that, I'm at 1.51. So here's 1. I'm going to estimate halfway. The next one I'm at 2. So 1, 2. And then I'm at 2.4. The next one is 2.7. And then 2.9, and then 3. So remember how we said these are going to be symmetrical? So now this is going to start, and you're going to see that right away, because look, after 3, see how these start repeating themselves? So this will be your 2.9, your 2.7, your 2.4, your 2, 1.51, 1, 0.48, and then this one's at 0. So I'm going to connect these. And then these are going to be symmetric as well. And so if you want, you can reflect those points, and that will create the rest of the loop. And I'm just going to show you here how you can graph it. And then, okay, see how little this is? So if you want to adjust your window, you can either zoom in or you can adjust your window. Either one should be fine. But then that's going to show you how you started it. So it loops and then back around. Alright, and then I'll take questions on that. And let you start your homework as well. Yeah.
So you know what's so